I am Shalini Sahay from Department of Electronics and Communication. I am uploading my video on experiment number 4 for the subject Signal and System ec402. This is the list of experiment which is based on the software MATLAB. Now today we will going to discuss the experiment number 4. Write a MATLAB program to find whether the systems are linear and stable. So first of all, we will discuss a theory based on the system properties linearity, stability and causality. The causal system is a system where the output depends on past or current inputs but not on the future inputs. The necessary condition is that the impulse response of the system should be zero, where Hn is the impulse response. That is, the output of a causal system at the present time depends on only the present or the past value of the input, not on its future values. Thus, this is a causal system. It is not possible to obtain an output before an input is applied to the system. So, that a system is called non-causal if it is not a causal. For the linearity, as we know that a system is linear only if it follows the superposition theorem. So, a system is linear only and only if we have given the condition. If the above condition is followed by the system, then the system is linear. Then the third one is if the signal or the system xn be bounded input sequence and the hn be the impulse response of the system and yn the output sequence. Necessary and sufficient boundary condition for the stability is that it should the response of the system should be bounded, which means that its value should be less than infinity. Now we have switch over to the MATLAB code. Now the sum of the element S is equals to sum x is the sum of the elements of the vector x. Now we have taken one vector B is equals to which has two elements 1 and 0. Second vector we have taken as A, that is equals to 1 and 0.9. Now we have assigned one random variable x1 which is equals to random 1 and 10 whose elements are this one. Now again we have taken another variable x2 which is equals to rand random number 1 row and 10 columns, means a vector which is having the 1 row and 10 elements, and it will select the random numbers. Then we have taken the output of the filter y2 is equals to filter b comma a comma 2 into star x1. Now we have taken another variable y5 which is also a filter response given by this expression. Then y is equals to filter b comma a comma x1. Now we have taken the another variable y0 which is also the give the filter response. Now we have taken as the output y6. We are following the linearity property. Then y6 is equals to y2 plus y5 and y7 is plus y0. If y6 minus y7 is approximately equals to 0, means the system is linear, else the system is non-linear. Now we will move to the second program. Again we have taken the variable n which ranges from minus 10 to plus 10. Then we have make one vector x is equals to zeros 1 to 10. This is 1, 0, 1 to 10, means it will for the negative value we will get 0, for the 0 we will get the 1, and for the positive values we also get the 0. Then y1 is the filter a comma b comma x. Now we will find the absolute value of y1. We have find the absolute value. T is the sum of capital T. If T is less than 1000, we have taken it should be less than infinity. For infinity we have assumed the largest assume the large number 1000. If the value is less than 1000, then it will display stable, else it will stay display unstable. So with this we conclude that the result of the system is either linear and stable. So for linearity you should follow the superposition theorem. So the superposition theorem, which states that the individual sum of the output of corresponding to the input should be same, means that the superposition, if more than one input applied to the system, then the output response due to the individual input should be equal. So this shows that the system is linear as well as the stable if the output is less than infinity, which means that the output should come to be a finite value. It should be greater than 0 and it should be less than infinity. Thank you.